Welcome to the lecture of voltage and current division rule. Here we are going to learn how the voltage and current division rule works. So our aim is to apply voltage and current division rule. Let's see how the voltage division rule works. This is the circuit in which we have connected three resistors in series, and this is the voltage source. Now we have to find what is the voltage across the first resistor, the second resistor and the third resistor. Using the voltage division rule, we can find directly what is the voltage across first resistor, second resistor and third resistor simultaneously. So we know that I is equal to what is the total voltage upon what is the total resistance. This is simple Ohm's law. So the voltage over the first resistor will be V1, that will be equal to I into R1. I is the main current flowing in this circuit and R1 is the first resistance. We can write in the place of I this equation V total upon R1 plus R2 plus R3. So we have put it instead of I the main equation. So by solving we can find that V1 is equal to V means the main voltage into R1 means for what the resistance you have to find the voltage upon the total resistance. So to find the voltage over an individual resistance in series, take the total series voltage and multiply by the individual resistance over the total resistance. Let's see an example. Here we have to find voltage across these two resistors which are connected in series. So I have to find the voltage across this resistance, first resistance. So according to what we have learned earlier, that we have to put the total voltage V upon R1 plus R2. This is actually I. I is the total current flowing in the circuit, means V upon total resistance. Similarly, we can find the voltage of the voltage drop across this second resistance or voltage across this second resistance by using the formula I into R2, but I is actually the full voltage upon full resistance what is connected in series. So similarly we can find V1 and V2 means the voltage across R1 and R2. So let us see in the next example how we have to find the voltage. We have to find the voltage of across this resistor and across this resistor. So what will be the voltage? This will be the V1. Here we are going to find V2. So the total current IS, this is the supply current IS, it will be the formula by the Ohm's law, Vs upon R1 plus R2 means the total resistance connected in series. Now the voltage across this resistance, first resistance R1 will be equal to V1 is equal to IS into R1 will be the main formula, but in the place of IS we have put it this equation Vs upon R1 plus R2. Similarly we have done for the second voltage which is across R2 resistance. Thus we have found that both voltage across the resistors. Now let's see the summary. The source voltage V is divided among the resistor in direct proportion to their resistance. The larger will be the resistance, the larger will be the voltage drop, as you all know. This is called the principle of voltage division. And in generally, if a voltage divider has n resistor R1 to Rn in series with the source voltage V, the nth resistor Rn will have a voltage drop of Vn, where it will be Rn upon the total resistance what is connected in the series into V, the supply voltage. Now let us see how the current division rule works. If we know the current flowing into two parallel resistors, we can find out how the current will divide up in one step. So what I have done, this is the two parallel resistor, this is the main current I, it is dividing in this I1 and I2. Now by the help of current division formula, we can directly find what will be the value of I1 or what will be the value of I2. So as we know that according to Ohm's law, V is equal to IR. This R equivalent I have written because I have to find the equivalent resistance of R1 and R2. Since these are connected in parallel, therefore in the place of R equivalent, what I have done, I have written the formula of parallel resistor equivalent, means R1 into R2 upon R1 plus R2. Now this current means I1 current, I have to find I1 current in branch, this branch. So I1 current is equal to V upon R. R1 means the resistor across which we have to find the current. Now what we have done, this V I have put it the equation, main equation, this one I have put it I into R1 plus R2, which I have derived in the first. V is equal to I into R1 R2 upon R1 plus R2 I have put it here. When I have solved this equation, I directly found this formula. I1 is equal to I into R2 upon R1 plus R2, means which branch, if I have to find the current, this is that value, means I have to find the current of I1, that will be equal to I, means what the current I already know, into R2, the other resistor which I am not finding now, upon total resistor what is in parallel. So in this way I can find current in each branch. Similarly for I2, I can find I into R1 upon R1 plus R2. See, for I1 I have written R2, but for I2 I have written R1. Make very attentionally clear that this equation is slightly different. Similarly we can find for the open voltage. For example, if I have to find I1 and I2 in term of IS, this formula can be IS is equal to I1 plus I2. Now what I have done, since the voltage is equal across both the branches, the voltage across this branch will be equal to voltage across this branch. Now we know that V is equal to I into R, means I1 into R1, and similarly V2 is equal to I2 into R2, this one. I have equated both the equation. I2 is equal to I1 R1 upon R2 only from this formula I have derived from this step, and similarly IS is equal to I1 plus I2. This is the value of I2, I have put it from here, this one, means IS is the supply current, total current, it is dividing I1 and I2. I have explained KCL. IS is equal to I1 plus I2. Instead of this I2 I have placed I1 R1 upon R2, and by solving I will get this equation. Similarly I can get the both equation. You can see very clear that how I have found these two branch equation of current. I can directly find the current across these two branches, I1 and I2. At least I have to know one current, one branch current. So in this equation I know IS and I know all the value of R2, R1. Okay. So similarly for this I have taken a live example to find the voltage and current. For the voltage division rule you can go through step 1, and for the current division rule you can go through like this. These two branches are connected in parallel. I have solved here, it is equivalent to 2. Now directly I can write that 4 plus 2 is 6, equivalent is 6. 6 upon 6 plus 3, because I have to find current across this branch I0, this branch I0. So I into 6, because I have to find this branch current, I will take resistor of this branch current. So this is the formula, I naught is equal to I into 6 upon total 6 plus 3, this 6 plus 3, and I have got the answer. I think you have learned how the current division and voltage division rule works. Thank you.